so now we do thermoregulation when you are too cold. So the stimulus is a drop in blood temperature. Okay, the receptor is going to be a thermoreceptor. In the hypothalamus. Again, it's the thermoregulatory center. And so the modulator is the thermoregulatory center in the hypothalamus. Okay. Now, once again, students love jumping straight to what is going to happen. Get everyone excited. Remember, slow down, plan your answer so you don't miss out on easy marks. If you are too cold, you're going to write
shivering.
Shiver.
But what we should go backwards and show that it's from skeletal muscles.
Shiver. We're going to write vasoconstriction. You're going to write goosebumps or piloerection.
Well, wouldn't it be erected pili?
No,
erection.
Now we're going
and we're
back
going to have
precisely.
increased
thyroid.
thyroxine.
Oh, yes.
Where did that come from?
Hormonal.
Let's
it's a
talk
hormonal
about it.
one.
So,
Increase
we're going to have
phase
from the
in
modulator to the effector, we're going to have either neural or hormonal signals. Okay? So shivering is neural. Vasoconstriction is neural. Piloerection is neural. And thyroxine is hormonal. Thyroxine comes from the thyroid gland, which is on your Adam's apple. So now we'll talk about the effector that brings about the actions.
Yeah.
So shivering is skeletal muscle. Remember, 20 hertz, so it contracts 20 times a second, and the friction generates heat. Vasoconstriction is your blood vessel. So the blood vessels move away from the surface of the skin, so you can't lose heat to the environment. Piloerection, again, that's the erector pili. They do accept the word goosebump, although I don't agree with that, because that's a layman's term. The actual effector is erector pili, is the muscle at the base of the hair that makes the hair stand on end to trap the air, which you then heat up, and it acts as an insulation layer. And then the thyroxine comes from the thyroid gland.
Basal
It does
metabolic rate.
increases the basal metabolic rate, and in particular, cellular respiration that generates heat as a byproduct. Okay, so the response now is an increase in blood temperature.
And then our friendly arrow.
Negative.
Well, then we say because we've now got a rise in blood temperature, we say that opposes the original stimulus. Opposes the original stimulus, we say that that is negative feedback. And to show the examiner that we are in control of the knowledge and we know everything there is to know, we get that arrow from the response back up to the stimulus and we put a negative symbol there and we write negative feedback there as well so that they know that we know everything there is to know about thermoregulation.
But if you're not doing your arterial diagram, can you just say the negative feedback? Do you have to draw the line?
It depends on the nature of the question.
Yeah. But would you have
You would decide. I would still mention, if you haven't drawn a diagram, you still want to make it very obvious that you understand what negative feedback is.
Yeah.
Okay? You might say, down here, oppose the original stimulus, which was a drop in blood temperature. And because it's high blood temperature now, it is completely contradicting the original stimulus. You would need to make it just very self-evident that you knew what negative feedback is, because a lot of students will just write negative feedback and again walk away from it.